As you begin to adopt AI in your organization, you quickly begin to realize that the LLM, ChatGPT or otherwise, is just a part of the process. There are many other systems needed to get the most out of these new tools, but almost everyone is confused about what these systems are and how they all fit together. And that's what this video is for, gaining a deep understanding of all the systems that surround the large language models so you can understand how to get the most out of what's currently available. This foundation will help you solve AI's most glaring problems and help you push its capabilities to unexpected new heights. The categories of these systems include agents, memory, guardrails, and prompt evaluation. I'll walk you through each one of these components, and then I'll show you how a non-technical person can get started experimenting with these. In the final section on prompt evaluation, I'll introduce you to an exciting new tool that uses AI to test prompts against each other, continuously improving your prompts and thus your results. As AI continues to proliferate the workforce, understanding how these systems work together will become ever more important. This video was greatly inspired by James Briggs' article, LLMs Are Not All You Need. I'll put a link to that in the description, and it starts with this really great graphic that shows that the large language models such as ChatGPT, Claude, all these other models that are coming out, is in a lot of ways the engine of a much bigger environment, and it shows how prompt engineering can improve the results there. And it works its way in a clockwise motion, going through conversational memory, which we'll get into, external knowledge base, and fine-tuning. We'll spend a lot of time discussing those. Code execution, we're not going to talk a ton about in this video. I have other videos related to that. You can check out my Getting Started with Google Collabs video that talks about code execution using large language models. And we are going to speak a lot about evaluation, about dialogue flows, about agents, and protective guardrails. So you can see if you're just trying to do it all with ChatGPT and not focusing on these other areas, you're going to struggle. But that's what this video is all about, explaining how these other pieces fit into a much bigger picture. And we're going to start with agents, which is a topic that has been coming up and it's evolving quickly. And these are basically ways to enhance the large language model and granting it advanced functionality. So if you want ChatGPT to actually go out and do something, or a large language model to carry out a task, it's going to have to use agents, and it utilizes various tools connecting software via APIs. There are ways to use it to execute specific codes or commands, and you can also use agents to get large language models to perform functions in parallel. The most common library for this is LangChain. If you've done any research into agents, you've probably come across LangChain. There are some amazing technical tutorials out there for it and all the great things that it can do. But if you are not a coder and you want to try this out, a couple places you might want to look at are FlowWise and LangFlow. These will get you started with some basic LangChain processes. You might need a programmer to help you set these up. There is some technical requirements just getting those up and running. One common use case for the agents is the React framework. So this is reason followed by action, and it shows how the LLM thinks, plans, and then executes its plan. You can see this if you've ever used Perplexity AI. As you may know, I'm a huge fan of Perplexity AI. It's a way to use AI to go out and do research online, and you can actually watch it. It tries to first understand your request, and then it goes out and searches the web for things that correspond to your request, and then it summarizes all those things, and you can see it thinking, you can see it moving through all those steps right there in the Perplexity interface. You are using, I think, one of the most successful use cases of agents so far. Here's another look at this. Again, this is from James Briggs' article. If you're just using the large language model and you feed in, this is a question about some Apple devices. And if the large language model is not prompted to think or not given time to go through multiple steps, it just jumps to an answer, iPod. But if you're using the React, the reason and then act agent framework, it starts to generate, here's a few different thoughts, and here's a few different actions that it can take, and then it compiles all of that into a much better result. So this is one example of agents, but this is how we're going to get these large language models to actually do stuff. Maybe you want it to actually start responding to emails or start doing some shopping for you, etc., and plugging into these other APIs. Agents are going to be how that is done. Moving on to memory, this is a very hot topic as people are always excited to try to customize these large language models in various ways. And we'll get into that here in detail. I think there's some terminology here that's very helpful. This parametric knowledge. It was in James Briggs's article that I first really started to understand this concept, that this is really just the training data from the actual training of ChatGPT. And at this point, that training data ended in 2021. And fine-tuning is a term used for actually updating that actual training data with new information. So a lot of people use fine-tuning to mean different things, but it actually has a very specific meaning, and that is actually retraining that model, updating its parametric knowledge with whatever data you're trying to impart into the large language model, such as ChatGPT. The other, and probably the most popular currently, way to update the knowledge that the large language model has access to is using this external knowledge base, or what's called a RAG process. Retrieval Augmented Generation is a way that folks are describing this. And this is how the knowledge is retrieved. The Hugging Face Transformers library does a lot of this. There are a lot of pre-built RAG models in there. And it uses the vector embedded database. This is where knowledge is stored. There are some really good software out there for this. Pinecone, Weaviate, and ChromaDB are the leaders right now. And if you want to experiment with the vector database in a no-code environment, I'd recommend checking out Custom GPT. There are a lot of tools out there that allow you to say, they'll advertise it as chat with a PDF or chat with a video or things like that. All they're doing is taking that information from that video or from that PDF, whatever the source data is. Maybe it's chat with your website is one of them, where they would take your entire website and they would embed that information into a vector embedded database, and then they would use the large language model to query that database. And I'll get through an example of that here in a second, but when you are thinking of integrating unique knowledge into ChatGPT or another LLM, this is a big decision that you're going to want to make if you're going to go the route of fine-tuning versus this route of this RAG or vector embedded database. That will be one of the major decisions. There are trade-offs for each of them. I would say the vector embedded database direction is by far the most popular because it is only recently become available that you can actually fine-tune ChatGPT, and I think it is more time consuming and probably take a lot more effort to get it right, but there are certainly situations where that would probably work better. Just a quick visual on that, because I know it's a little bit esoteric to understand, but the RAG example or the vector embedded database example, to set this up, you would need to create a vector embedded database. I'm going to use this example of the Olympics, the 2022 Olympics, which current ChatGPT has no idea what happened there since it was trained on data ending in 2021. So this is an example that is in the OpenAI cookbook section. I believe it can walk you through how to do this, but you would basically take a bunch of information about the 2022 Olympics, probably straight off of Wikipedia is how the example would work. You can scrape it right off of Wikipedia and create that vector embedded database, which is just turning all of that text into a bunch of numbers that the large language model can understand. Then when you prompt it and you say, hey, who got the most gold medals in the 2022 Olympics, it goes straight to the large language models, and that model would say, okay, I have this vector embedded database. Let me go check that. And it pulls a bunch of information out of that vector embedded database, and it creates a new prompt for itself that includes all of that information, and then it gives you the output. So if you think about it, it's just using that vector embedded database to update the prompt with new information, and that's a lot of the times where you're going to have to make that work. As what information is it grabbing? I think that's one of the major challenges with this, workflow is making sure it is grabbing the correct information from that database, especially if it's a very large database, it's very complex questions you're asking it. But then it grabs that, updates the prompt with the information, and then it tidies it all up and answers your question. So that is the RAG example. The fine-tuning example, to set that up, you would actually retrain the large language model on the 2020 Olympics data. So it would become part of its parametric knowledge. It would be in the model itself so that you could just prompt it and it would go into that fine-tuned model and it would give you the right output. So this one seems like it might be more straightforward, but that retraining process is very time consuming and there's a lot of ways that it can go wrong, especially if you're training it on a lot of information. Those are the two different ways to update the memory of the large language model. A couple more thoughts on memory, the context window. When we talked about using that knowledge base, that method, that RAG method, you are actually stuffing the prompt with a bunch of knowledge. So this is called context stuffing, when you put the updated knowledge actually in the prompt, which is what a lot of folks do, what I do. You want to think about this context window because it can only handle so much information. Anything beyond a couple thousand tokens, you'll start to experience decreased recall. And this is particularly for the information that's in the middle of the prompt. So you want to make sure the most important information is at the beginning and the end of the prompt. Conversational memory is a little bit different. This is the back and forth that happens in that conversation. So that context window will then look back on the conversation and look at everything that you've asked as well as everything that the large language model has produced, and all of that needs to fit into that conversational memory. This is why if you've been going back and forth with the large language model, it might start to forget some of the things that were put in early on. So ChatGPT right now has a context window of about 8,000 tokens, which is roughly 4,000 words. So this is a barrier to keep in mind as you're uploading information to it. It is true that after a couple thousand tokens, so maybe 1,000 words, 2,000 words, it's going to start forgetting things and start to decrease its capacity. Claude is really something you might want to check out if you're looking for a larger context window. It has 100,000 tokens, so it can remember roughly 50,000 words. It's especially good for writing. It's been trained specifically on essays and things like that. Moving into guardrails and flows. This is a concept that is not talked about nearly as much as some of the others, for sure not as much as agents, but I think it could be incredibly important as we move forward into this new realm of AI. These are hard rules that control how the large language models behave. So, example, if you're building a chatbot to help people order pizza, this can help you stick to that pizza topic, where you can put in a guardrail and say, hey, is this question about pizza? Okay, we can answer it. We can help this person order a pizza. Hey, is this question not about pizza? And then, okay, we can handle that in various ways. So the most popular tool for this is NVIDIA's NeMo guardrails. So if you're working with developers, this might be a direction you want to point them. The categories, so like in our pizza example, there might be pizza related questions and non-pizza related questions. Those categories are called canonical forms inside of that NeMo's guardrails framework. And training that data requires examples of text that point to different canonical forms. These are called utterances. So examples of a pizza-related utterance would be, what toppings do you have? Examples of a non-pizza related utterance might be, who's going to win the World Series? So to put this in place, you might want to come up with a lot of training data on pizza-related questions. You can even use ChatGPT to create 100 pizza-related questions and then create 100 non-pizza-related questions, label those in their various categories or in their various canonical forms, and then you are off on your way to creating some guardrails for your pizza ordering chatbot. And this can get a lot more complex if you are maybe trying to get the model to understand a lot of information about your your organization. You might want to create different categories such as sales and marketing or operations. So if you're building an assistant that's a company-wide assistant, someone goes to it with a sales and marketing question. Oh, it knows these guardrails are taking it in a direction of the sales and marketing database or the sales and marketing portion of its brain or memory. Or maybe it knows from the question this is an operations question. I'm going to go to the operations section. And in that way, you can drill down into the most accurate information using these guardrails and flows. If you want to experiment with this, there is a bot press is a good way to experiment with these guardrails and flows. I think Stack AI is another one that you might want to check out if you want to experiment with this in a no-code, easy user interface there. So prompt engineering and evaluation. There's been a lot of talk about prompt engineering. It's still a very important part. The very basic of it is, I think, helpful to remind myself of is just give it a role and a goal, such as you're an Italian pizza chef, please generate an authentic pizza recipe. So it's by telling it you're an Italian pizza chef, it goes into that part of its memory, and then it starts to look for an authentic pizza recipe. Maybe you wanted a more American style pizza, and you might want to say something like, you are a pizza chef at Domino's Pizza, please create a Domino's Pizza like recipe. And that way you can control it a little better than just saying, hey, give me a pizza recipe that's going to be right in between those two things. If you've got some fancy friends coming over, you want to impress them and create something that is very authentically Italian. Or if you just have some friends coming over to watch the game or whatever, and you want to create something that's more American, you can steer it in those different directions. If you want to get a little more fancy with your prompt engineering, this is another great framework I got out of that same James Briggs article, giving it the instructions. You tell the model what to do, how to behave, how to structure its outputs. You want to give it some external information, some source knowledge. This gets back to the context stuffing. So putting a bunch of relevant information in there, making sure you don't go over 1,000, 1,500 words or so, giving it a few shots. So a few shot prompting would be giving it a few examples of here are some correct ways to answer this. And then the user input is the query, which the user would put in. So most people just think of the prompt as that user input, as that query, but adding these other elements to it can really improve it. And one way to greatly reduce hallucinations is by dropping this into your custom instructions. I don't know how deeply you've gotten into custom instructions. There's a lot out there, and a lot of folks are getting really fancy with them. For me right now, I'm keeping them pretty simple and just putting in these little snippets, such as when you do not know the answer to a question, truthfully say, I don't know, and that'll reduce your hallucinations right there. You can turn on your custom instructions in the settings down at the bottom left of the ChatGPT Plus. And now I want to show you a really cool tool that I'm very excited about related to evaluating your prompts. This is called Prompts Royale. Previously, this was not available in a no-code environment, but this automatically creates prompts, and then you can make them fight with each other to decide which one is best. So I'll show you this here. You plug in your API key, and this will allow you to generate prompts and get them to battle each other. This is a way of basically A/B testing your prompts and continuously improving them. So I'm really excited about this. I want to do a new video all about this. Prompts Royale. I think this will be very powerful to improving your prompts. And just a quick summary here. LLMs like ChatGPT are great, but they're far from perfect. They're prone to unpredictability, errors, lack of specific knowledge. And the ways that you can handle that is with agents, getting the large language model to actually get out there and do stuff, getting it to think on its own, getting it to interact with different tools and APIs. Memory, at the parametric memory, which is the trained memory. We looked at fine tuning. We looked at using the RAG process and vector embedded databases. And we looked at the context window, all the various ways that ChatGPT and other large language models get their information. We looked at guardrails, which is ways to put up guardrails to keep the conversation going in one direction or to steer it into different parts of its database as need be. Looked at prompt engineering and evaluation, specifically that Prompts Royale is a tool I'm really excited about to be able to test your prompts and improve your prompts in a low, no-code environment. And all of this, I think, will help you really get the most out of these large language models. I have a cheat sheet version of this available to all my Patreon subscribers. It's got everything we went through here if you want to share it with your team. It's got a lot more on LangChain in particular. I think agents are the part of this that is evolving the fastest. So these are a bunch of different resources all around learning LangChain and how to get the most out of the agents that are being built around these large language models. So please check out the Patreon. It really helps support this channel, helps me keep creating these videos. If you got something out of this, please hit the like button, hit the subscribe button, shoot me a comment in the comments section, and I will see you on the next video. I really appreciate you watching.
Just do it! Make your dreams come true!